Okay, so letter A, it's talking about f of x. You can see there's f of x, g of x, and h of x functions given to you. So make sure you're picking the right function that we're talking about. It says as x approaches 0 from the left. So looking at this function, is the top piece or the bottom piece the one that I'd want to look at if I'm coming from the left? The top, okay? So all you do is plug 0 into the top, and what do we get? -3. Do you guys remember this? Okay. Try B through H for me. Ready, go. We're just jumping in.
Does it matter what the signs are? How do you do it? Equal 0.
Doesn't matter, because remember with a limit, it doesn't have to, you just approach it, so yeah.
E to the 0 is 1, right?
E to the 0 is 1. Good job.
Well, you said try B through H.
Yep.
Oh, that's not true. That's like 0.
No, it's the bottom. The 0 is the
No, G is 1. G is no.
If you go on like a number line,
These things make some bigger amounts. We were talking the other day about like bigger all-star colors, and you said wow, so I tried it. Like I asked him if he wanted some. He said sure, so I bought him. You like it? Yeah. Wow.
For letter E, so as x approaches 1 for g of x. Yeah.
So this would be.
It doesn't matter that there's just that point at 5. Like,
No, I was doing it because this is greater than the last one.
that's fine. Remember the limit? That point doesn't have to exist. You can just come right up and look in the hole. Are we ready, guys? Yeah? Okay. All right, guys, up here, let's go through them. All right, letter B. We're looking at f of x still. As we come from the right, when you plug that in, 0 squared, that's easy, that's 0. Guys, what's e to the 0? 1, okay. All right, then C, what do we get? DNE, the left and the right did not match. All right, and then df of 0. Which piece is it actually included in? Yes, the bottom one, and you get 1. We okay with the f function? Okay. E, limit of g of x as x approaches 1.
3.
It is 3, but let's look at y. This piece in the middle here, this 5 as x equals 1, that's just a single point. Okay? This is actually from the left, and this one is from the right. So you don't even need that middle piece when you're evaluating the limit. Okay? If I plug 1 into both of those pieces, I do get 3. Do we see it?
Yeah.
Okay. That 5 in the middle there is just a message. Yep, because you need to see if they match. All right, but then g of 1, what is the actual function value? That is what is 5, yes. We're getting the difference there? Okay. All right, h of x as x approaches -3. This is weird, right? The way this is written, it's not going to be just 0 over 0. We can't, remember 0 over 0 is, oh no. Well, you're not done then. Okay, you did more after 0 over 0. Factoring? What are you saying, shut up? All right. All right. Oh, no, what? It just means don't stop if you get 0 over 0. You can't end with that. If I look at that h of x function, first, guys, do you understand why I only need to look at the top piece of that piecewise?
No.
Okay. It's... You sure? Okay. The other part of it is just a singular point, so that's not going to have anything to do with the actual limit. So we need to look at the top piece. I'm going to factor that. The numerator would be x minus 3. I guess I don't need h of x. Times x plus 3. And then the denominator factors into x plus 4 and x plus 3. What can I then cancel out? Okay. Then you can plug in the -3. Do not write limit once you're plugging in the number. You can just tell me what that's going to equal. And we'll get -6 over 1, or just -6.
Wait, sorry, why are we only using the top part?
So if you think about what this is saying graphically, this equals 0 when x equals -3. That's a singular point.
Okay.
The entire rest of the graph is from this top piece.
Okay. So it's still just approach.
Yeah, like if this is not what it looks like, but it's like you have an asymptote, you've got a graph, you've got like a hole, a point, and a right? Like
Okay. Yeah.
this doesn't actually matter for limits. Okay. And then h of -3, what you guys get for that? That one is 0, yes. We okay? All right, second example. Nice. Oh, Jake.
We're still so confused. Yeah, like, why do you plug it in when it says X?
Okay, so let me make a simpler one so you can see the graph of it, but same idea. Let's say this is like x plus 3, and this is when x does not equal 2, and it's -4 when x equals 2. Okay, let me just graph this. Like that's the bottom part, right? Just that singular point. And the top, yeah. You'd have that going on. Okay? So if I ask you the limit as x approaches 2, does it have anything to do with that dot down here? No, it's all from the top piece, right? So it's all from this part of the function. Does that help? It matters for function value, but not limit. Like if I said, what's f of 2, you'd say -4. But the limit part is not. Is what? Say it again. Like if you're on this graph walking along, you're not approaching that dot, right? Okay. Could we just plug it in? And was it two different things from the left and from the right, or was it the same equation? So that's why I didn't have to do multiple pieces, yeah. Good questions, guys. All right, the bottom. It says find the c value so that the limit exists when x approaches 2. Okay, one of these pieces I don't care about at all. Jaden, up here, guys. Jake. Which piece, the top, middle, or bottom piece, do I not care about? Can I just get rid of? The top piece. Why the top piece? Yeah, that has nothing to do with 2, and I want to know about the limit as x approaches 2. So I can just ignore that top piece. And then think about it. If the limit exists at 2 when you have a piecewise function, this is not what this graph looks like, but if my graph was here and then it jumped down here and did that, does that limit exist as x approaches 2? No. I need the two pieces to like run into each other, right? They have to like overlap at that point right there. Yeah, so you need the y values to be the same, meaning you need these two pieces to equal each other at what specific x value? 2. So you plug a 2 in and you solve for c. Magic. Where'd I lose you? What? For the limit to exist, the left and the right have to match, right? The y values have to equal each other, yes? Okay, so I said the two pieces, the one from the left and the one from the right, equal to each other. Well, what x am I approaching with my limit here? I didn't just randomly pick a 2. It told me to pick 2. Okay, then we're back to Algebra 1, and I think you can solve for C. I believe in you guys. Step 1, you didn't quite get? That's fair.
I feel like I made it 3. Yeah.
It's on the board.
How are you getting 5? See? Sometimes that's the case. Oh dear. I did not anticipate that being the hard part, but you know? Yeah, you're just finding C. Yeah. Okay, we'll put one of those on. All right, are we okay? Jaden, are we at 3 halves? Maybe? Yes? No? Jaden, are you at 3 halves? Okay.
I got it.
Woo, okay. All right, guys, turn your paper over. All right, this is a whole lot of writing that is very, very simple, and you've actually already done. Okay? The first couple here, guys. Yiming, turn around. Yeah, you don't need to share a desk with someone, okay? You can have your own desk. These first couple we've done already. Like limit of a constant, if I said limit of 3 as x approaches 5, it's always just going to be whatever the constant is. Okay, because that's a horizontal line, you approach that. We've done that before. The identity one, you're just plugging it in. So like if x approaches 4, you plug in the 4, you'd obviously get 4. Like those are very, very simple things that you've already done.
Why would the second one not be
C is the value you plug into x, and that's what the answer to the limit question is. And 10.2. The coefficient rule. Hey guys. Coefficient. If you have a coefficient in front of your limit, you're just multiplying whatever you get by that coefficient. Okay, so if it says limit of 2 times f of x as x approaches c, you're just going to multiply by 2 at the end. Okay, they're very common sense. Like you do what they seem like you should do. Addition rule. Find the individual limits and add them together. We did that on 10.2 with 2 graphs. Do you remember it was like this graph approaches 3, the other one approaches 1. We said 3 plus 1 is 4. Yeah. Subtraction, multiplication, division. Those are all just do what the operation says. Evaluate them individually, do the operation. Yes.
Guessing you will not have this on the steps.
I'll show you examples and you might have one. They're not hard. You don't have to like know the notation of this.
Yeah, no, do we have these rules?
Oh, no.
Yeah.
I thought you meant, will we have these questions?
No, we definitely will. But
Yeah.
I was asking if we'll have like.
No, but they're,
like that.
you should, like, when it says add, you add them. Yeah, so it's not. No, there's nothing quirky with them. Yes. Sure. Why is there?
L plus N, L minus N? Like
This is your final answer. This is your final answer.
the second.
Yeah, those
Like, do we just like not? That's just our answer. That's
Right, so like it starts as this. You can turn that into this, and then it equals this. Yeah? Okay. I thought you meant there was like an equals somewhere. Okay, let's try one so you can see that these are not scary. All right, so letter A, limit as x approaches b of f of x plus g of x. Evaluate them individually. What is the limit as x approaches b of f of x? 7. Plus, what is the limit as x approaches b of g of x? So what do we get?
4.
And you are done. Do you see what I mean? They are not hard. Don't make them hard. Okay? Try B, C, and D.
so is that the kind of question we're gonna have?
Mm-hmm.
So like we don't
No,
have
this
to
is a
memorize
joke.
it. It's just
You just, like, it's intuitive, right? You don't need to, like, memorize the notation from up above.
Wait, can we just skip to that?
Skip to the end.
I'm still kind of lost. Like on the test was 6 questions. Yeah.
Sure.
Good.
Yeah, right? We would like these. You'd like a whole page of these. Well, I think you would like a whole page of these. I don't know. Maybe someone doesn't like them. All right, guys, what'd you get for B? Yep. What about C? Yes. And D? Okay. Everybody happy on those? Okay. All right. Try the last one here. You have this big, I'm just going to rewrite it over here so we can see it, but there's not really any like notation that you need to be doing. Could you evaluate each of those limits individually? Yes, and then just do the operations they are telling you to do. Okay? You don't need this column of the table at all. It is just there to mess with you. Yeah, it's just there to mess with you. Like, oh, do I need those? No, you do not. Because you might think like, oh, do I just plug the 3 in? No, you evaluate the limit. That's what it's doing. Just it's not 32.
Not this week, but next week.
Okay. What's 4 plus 24?
Why don't I multiply? Why don't I multiply 2 times 4? Oh,
You already. This is 2, right?
yeah.
This is 4.
Yeah.
Plus it, right?
Oh, because that's in the. Oh, I didn't even. Yeah. All right. So. 56.
There we go. Yes. You evaluate them all individually, guys. Limit as x approaches 3 for h of x is 2. 2 times the limit of f of x as x approaches 3, another 2. 3 times the limit for g of x was 8. Then it's just PEMDAS. It's just order of operations. So you have 2 times 4 plus 24. All right. Questions, guys? We're going to do a quizzes first, and then there's delta. Okay?
Like average.
I'd say average. Yeah. There are some. Yeah, you're not wrong. Yeah. Yes, good. We end on what I think is probably the easiest unit of the year. Like if you pay attention, right? If you listen, and it's not hard. If you just are doing whatever, this could be very hard. All right, guys, join quizzes with a partner, please. Excuse me.